What? 18? For real, for real? All right, 18 looks something like this. So it asks for end behavior. So both ends are the same. As x goes to infinity, the graph goes to 0. And as x goes to negative infinity, the graph goes to 0 again.
Oh my gosh, okay, I did -2, but I was gonna do 0. Yeah, I did.
Say again. The right side and the left side. Yeah. 15 looks a little funky. 1, 2, 1, 2. But it does. It still looks to me like on the right end, as x goes to infinity, it looks like they're both going to 0, left and right. They're both coming up to 0, coming down or up to 0. Nobody asked about it. Then both of them down. Both of them negative infinity.
I keep looking at the one going up and down, not the one going up. And I had changed mine because I circled where I do it, and I changed it.
Now, when you're on something like this, and we'll get to where we describe whenever we start talking about vertical asymptotes and what it means to be a vertical asymptote, we'll start getting to things like as x approaches 2, then what does the graph do? But the problem is I can't just say as x approaches 2 because it approaches 2 from 2 different ways. And again, we'll get into that. We'll say 2 from the left and 2 from the right. So we won't do that just yet. F of x is your y value, your range. Okay. 17. I'm just kidding. As x approaches infinity, f of x approaches 1, 2, 3, 4, 5, 6, -7. No, because it doesn't. There's an asymptote there. And then the left side as x approaches negative infinity, f of x approaches positive infinity.
Yeah, I got that.
No, I haven't yet. This looks like, what number is this? 7. This is -7. So as x approaches infinity, f of x approaches -7. And then as x approaches negative infinity, f of x approaches infinity. You think there's an asymptote there? I don't think so. Look at the difference in how fast it is going over as opposed to on this bottom. Like this looks like it's really hugging out. To me, this looks like a decay graph, which doesn't have a vertical asymptote. Yeah. But I see what you're like. Look at 13. Look at the bottom half of 13 and how that looks whenever it has that vertical asymptote, how it starts hugging that line as opposed to 17. To me, it looks a little different.
It's like it goes close to the line longer.
Yes, yes, yes.
And 13 would both have to be,
Yes. 13?
Oh, yeah.
They both got a positive 3. Yeah. There's a horizontal asymptote at 3. So they're both, even though one's like this and one's like this value is 3. So they're both approaching 3.
So it's,
Yes. Oh, 16, yeah. 16 is as x goes, so you got something like this, right? And then something like this. As x goes to positive infinity, f of x goes up. And as x goes to negative infinity, f of x goes down. 16. So there's an asymptote here, but that's not impacting either of these ends right here. It's a vertical asymptote, not a horizontal asymptote. Now we do have a slant asymptote, but y'all haven't learned about those yet. We will though. Oh, yes. As you go to positive and negative infinity, you look at horizontal asymptotes. So jumping ahead a little bit, but that's okay. It's the definition of a horizontal asymptote. We will find that out. What you confused about? Look at your far ends, to the far right or far left. Don't look at the middle. Okay. I'll make some. Y'all ready for symmetry?
yes.
I doubled us up today. It's not because it's not a lot and it's not real hard, and you'll see why. It's really things that you've already done. We just call them different things. This unit is pretty easy, I think. So we're gonna try to get through it. So we're gonna talk about symmetry first. Did we talk about symmetry in algebra 2? Even and odd, the rotational versus the reflectional. Somebody, anybody, everybody scream. Do it, Joyce. There's squirrels in my pants.
No, I don't use Desmo. I actually boycotted Desmo a long time ago, so I don't use it. Rapid. I have a Desmo. That's so sad. I have Alex bookmark.
All right, ready? Yes, we are. Here you go with symmetry. So we got 2 types of symmetry. We have, I don't know what they want you to put on. All right, 2 types of symmetry, even and odd. When it is even, we say it has reflectional symmetry, and the axis of reflection is the y-axis. So reflectional, it is symmetric. About the y-axis. I don't know. Y'all always want these little things, but they're a bit confusing to me sometimes. Nuh-uh. Okay, well, let it be a challenge then. Let me show you how to do it, and then you figure out what they want you to say. There you go. Bet. All right. Think about a good example would be a parabola, the parent quadratic graph. Okay, that has symmetrical, that is symmetrical about the y-axis. It is an even function. Okay. Odd is also what we call rotational symmetry, which means if you rotate it 180 degrees, it maps back onto itself. Okay, so let me show you. What? Oh, reflectional. Y'all remember me showing you this? I always show it with symmetry. No? Okay, well, this is what reflectional. See how it's the same? The y-axis cuts it in half. It's the same on either side. If you folded the paper in half or you held a mirror up in the middle, they would be the same on either side. As opposed to rotational symmetry, whereas if you put your pencil right at the origin and you twist it 180 degrees, the graph would look exactly the same. That's an odd function. So odd has rotational, even has reflectional. Everybody good? I don't know that reflectional is a word, but the y-axis, yes. That's just saying that it's symmetrical.
I don't think it's a line. It's the actual like it doesn't have it flipped, but it's saying that oh that one you can't flip to the other side.
Oh, that's supposed to be the x-axis and the y-axis are common lines of symmetry. Right. Well, we don't use the x-axis for functions because then it wouldn't be a function. Right? And we really just talk about functions. Right. Right.
What's the length of the column?
The origin. No crumbs.
No crumbs.
All right, let's keep moving. I don't like x-axis symmetry. We never do that. We just do y-axis symmetry. Okay. All right, here's what we do. Everybody can graphically look and tell. Okay. All right, so that's graphically, algebraically. If you change every x to negative, and it gives you a completely opposite equation, it is an odd function. Remember, odd functions have rotational symmetry. But if you put a negative in for every x, and what you get out is exactly what you started with, then it is an even function, and of course that means it's got what kind of symmetry? Reflectional, right. Oh my gosh, have you ever seen that SpongeBob where they talk about an earworm and he keeps singing the same thing over and over? I have an earworm. Parker did that all night and all morning. Somebody, anybody, everybody scream. Ah, there's squirrels in my pants. Really?
Yeah, they're coming out on Disney Plus.
What? Did you say purr? All right, let's look at some examples. We'll look graphic and then we'll look. See how easy this is, and you've really done it. Look at number one. Number one looks like this. Reflection. So what does it ask us to do? Symmetrical to the x-axis, y-axis, and or origin. It's the y-axis. They're talking about rotational if it's about the origin. Rotate. Right. So like number two is symmetric about the origin. Not symmetric, but rotational about the origin. That's what they're getting at. If you twisted that 180 degrees, it would look exactly the same. Just like this. If you put your pencil at the origin and twisted that graph, it looks exactly the same. That little, on number two? Yeah. What? Y'all don't think so? Just hold it upside down and does it look exactly the same? Oh, okay, let's confirm algebraically. All right, this one is x to the fourth minus 4x squared. So if we put a negative x in for every x, right? So negative x to the fourth minus 4 to, nope, no number. You raise it to an even power, it forces it to be positive, right? So x to the fourth, again, forces positive minus 4x squared. It looks exactly the same, which tells me even, which tells me the y-axis is the axis of symmetry. Okay. I much prefer algebraic myself, but you do f of negative x, and then you say, okay, whenever I do f of negative x, does it look exactly the same or completely opposite? Correct. All right, so number two. Number two says xy equals 6, and it looks something like this. And I know that this is an odd function because if I rotated it 180 degrees, if I could just go whoop and put it upside down, it'd still look exactly the same, right? That piece of grass, I'd still have it in the top right and bottom left corners. And they'd be the same, right? Does that make sense? All right, no. Did you say no? Oh, I'm sorry. Okay. If I want to do f of negative x, I probably need to solve this for y first, right? It'll make it a little easier to see. Or you can just know that what you're looking for is that all the x terms are negative. But all right, y equals 6 over x. Agreed? So now if I do over negative here, dividing 1 by a negative is the same thing as just putting a negative out front. It's completely opposite, which tells me it is odd, so it confirms my origin's rotational symmetry.
Because you had to make it y.
Yeah. It's easy to see in this one, but if it wasn't quite so easy to see and wasn't solved for y, like number 3, it might be a little bit harder. Yeah. Yes, origin. What do you think about number 3? It would be across the x-axis. We don't worry much with that kind. We wouldn't justify that, not for us anyway. If the x-axis was a line of symmetry, if you folded it over on the x-axis, it'd look exactly the same.
This is the x-axis, and it's like this if I fold it over.
Yep. It'd be
And
the
the
same.
y-axis.
That's correct.
So how would you solve that one? Got you, Ben.
Hamburger, hot dog. How would you what? We won't do that one. If you see any that are symmetric about the x-axis, we won't do it. But it would be exactly the opposite. You'd put a negative in for every y to see that it negated the equation instead of the x's.
So the number 4, would that be both the x?
All right, so let's look at number 4. Number 4 is y squared minus x squared equals 1. It looks like all of them.
I said all of them as y. Because if you want it over y.
Okay, so let's put the negative in for x and see what happens. If you made this, and remember we skipped implicit, explicit, but if I made this in terms of x, right? So I solved it, so I get y equals 1 plus x squared, y squared, right? What happens is I square root, so this is plus or minus the square root of 1 plus x squared. That's why I have two different pieces here. Here's the positive piece, here's the negative piece.
I see.
You with me? So technically, I could, if I took the primary root, the positive root, I could make it look exactly the same. But if I put the negative in front, I could make it look exactly opposite. So I could show, technically, I could show that it has even and odd symmetry at the same time. Does that make sense? It could be, yeah. It could, depending on how it's graphed, because normally I would just graph this. That would just be the positive root, right? And that's just going to be right. So it's a little different. This is actually a semicircle. Yeah. Well, 1 minus if I had the, yeah. Say that again. If I solved that equation for y. Yes, ma'am. I'm going to let you know. I don't know which ones we're going to do from there yet. Probably handpick some of them because some of them are stupid. Yes. What do you think about number 5? I'm hearing different stuff. Why, Zoe? It's none. But if I twist it about the origin, okay, so this one, if I twist it about the origin, if this was the point and it rotated 180 degrees, it wouldn't look the same. It'd be shifted over one the other way.
Yeah, okay.
You see what I'm saying? It would end up looking like this instead of like that if I twisted it. Does that make sense? So none.
Yeah.
Can't be y-axis or x-axis because if you fold it exactly on that axis, it wouldn't work, right? And then if I try to do the whole algebraic thing, well, it's an odd root and I could have that, but here it's not completely opposite. It has to be completely opposite. So in other words, to be odd, I would need it to look like this at the end. Well, I could factor out a -1. Negative cubed root of x plus 1, but look, every sign has to be different, and it's not. I mean, sorry, circled the wrong one. The x have the same sign. If the x was negative in the red one whenever I did it, then yes. Right? Okay, let me show you. Let me show you. An odd would mean that they're opposites whenever I plug in a negative, right? What is the opposite of the cubed root of x minus 1? Well, I could write that this way, a negative in the beginning, or I could write it as this. Those are the same things. Yeah. the negative x plus 1, or all I've done here is factored out a negative 1, because the cube root of negative 1 is negative 1. So here, because I've got a negative out front, but this, it's not the same. You have to be able to take whatever your function is, whatever f of x is, whatever the whole equation is, put a negative in front of the whole thing. Now, whether that distributes through, yes, yes. If you can do that and make that happen, it's the same thing. Think in terms of a polynomial, okay? If I had x squared minus 3x plus 2, if I wanted negative f of x, I could write it this way, or I could write it this way. Both of them are the same. I could either change every single sign, or I can put a negative out front and put it in parentheses. That's kind of the thought process I'm doing here. Okay. Y'all okay? All right. How about number 6? Y-axis. We can tell it's y-axis. Sometimes it's easier graphically to tell, right? So y-axis is down here like this. I have y equals negative absolute value of x minus 2. How about algebraically? What's the absolute value of negative x? X. Does it look exactly the same or completely opposite, or neither? Exactly the same. Exactly the same means even. Even means symmetric about the y-axis. So it justifies algebra. All right, let's do some just algebraically, because that seems to be where we're getting stumped. F of x is x cubed minus x. Is it even, odd, or neither? Why? If I put a negative in for every x, to the third power keeps the sign, right? So negative x cubed plus x. Everything is completely opposite. I could write it, and maybe I should write it like this to help you see. I can put a negative out front of the whole thing, and it works, and it's odd. Yes, ma'am. Yeah. Yeah.
But if, say, we did this and it was negative x to the third minus x, would that be odd?
No, that would be neither. Yes. You mean after you plug in and simplify? Negative x to the third minus x. No, if only the first sign. If you can't factor a negative 1 out, and what's left in the parentheses looks exactly the same, then it's not odd.
So I could have the negative x cubed plus x and still got odd, right?
Yes. Yes, no, you didn't have to do that. That's what I was helping them understand, because that's what.
That looks the same.
Right. Looks the same, but there's a negative 1 out front of the parentheses, but yes.
So if it's even, we simplify it, that's the same.
Exact opposite.
How is it not?
No, not one little tiny thing.
The sign?
All signs inside.
Okay, so all signs are opposite. How is it not?
And I'm hesitant to say all signs, because what if it was a fraction, right? What if I started out with this, and I ended up, whenever I plugged, and you wouldn't end up with that here, but I'm just saying, what if I ended up with negative x squared minus x, or plus x over x? That would be odd, because even though the bottom's the same, by definition, you only need the top or the bottom to be opposite for it to be opposite.
Yeah. Okay, so something is opposite.
If you could take it, if you multiplied by negative 1 and you got what you ended up with, then yes, it's opposite.
Okay, how is it not?
Okay, look at number 9. Yes. I got x cubed minus x squared minus 2x. So whenever I plug in a negative x in this one, right? F of negative x, I've got negative x to the third minus negative x squared minus 2 times negative x. So let's see what happens. The odd exponents keep the sign the same. The even exponents force positives. And then I've got a negative times a negative, so plus 2x. So as I look at this one, opposite, same, opposite. None. If I take a negative 1 out of this, x cubed plus x squared minus 2x, that doesn't look exactly the same here. That's none. If this sign right here had been a plus, it would be none. I mean, it would be opposite, odd. Yes. This would be origin, or odd is origin algebraically. Even is the same, yeah. Well, I thought it was because we did it. Okay, try number 11. Okay. Try number 11. Negative x, negative 8 over x. Yeah, I'll do 10 ones. Okay. We'll do 10 and 12. Those both have.
No, I don't think I know. Oh, we're doing 10 and 12.
Yeah.
No, 10, 11, 12.
What did y'all think about this one? Even, odd, or neither?
This is what I got.
How is it odd? The fraction as a whole. If I can take this and put a negative 1 out front, what's left? I would have to make that negative, and now that's exactly the same, so it's odd. If you can do, if negative 1 times f of x equals this, then it's odd. I'm showing it a bunch of different ways, but it's. Tell me this, what makes a fraction negative? A negative what? Do both of them have to be negative to make it a negative? No, just one, right? If I do this, that's the same thing as saying this. Or I could say this. Do you agree or disagree? All of those are the same, right? So if I have just a over b, what if they're both negative? It's positive. So these are completely opposites. So 8 over x is complete. This I could rewrite as this, and it's still the same thing. Just because I put a negative out front fraction, right?
Wait, I did it right. I just put 10 is 10 even.
Yes.
Well, I did this.
Yes. It's a semicircle. Like this. Okay, so if I put a negative in here, right? Is this, first of all, what is negative f of x? Is there any way I can make this look like this? Absolutely not. So it's definitely not odd. It's not even either, so it's none. Yes. Yes. All right. 12 is absolute value of x plus 1. Okay. Without thinking about what it looks like graphically, because if you think about graphically, you know it's going to be even, right? Okay. Let's think about.
I'll work it out. And I understand that if you exactly no, babe. I don't like when you do that the negative one right here.
It doesn't. It doesn't. Wait.
So it's odd.
It's not odd.
It's not. I mean, it's absolute value of negative one. It's none. If you don't take out the negative one, you just put the x positive. And then it's x plus one. Well, yeah, but if you do that, it's out of the absolute value sign. No, I didn't take anything out. It's but positive. When like if you have negative 3 and an absolute value sign, your answer wouldn't be positive for the absolute value. It would just be positive 3. Oh, because the absolute value sign. And you have
Shift it up 1. If I knew my stinking transformation rules. Ah! You don't go up 1, you go left 1, and that has no symmetry, so everything we've done made sense up until I was an idiot.
So it's not.
That's what it looks like. It's not. It's not. I need to truncate this off of my recording. Okay. This is even. This is none. Because this one, I cannot believe I sat here. This one. Y'all, what if I'm losing my mind?
I got it. I just worked it out and got none. That makes sense.
Thank you for trusting me still. What did you put? Yeah, for the way we've done, yeah. I'm so sorry. Are y'all so disappointed in me?
No.
I'm disappointed in me. Oh my gosh. I sat here that entire time going, it shifts up. It has to be even. How am I going to make it even? Yes. This is your first introduction to calculus. And it is the easiest thing, and I don't know why, but every time calculus kids find the average rate of change, it is nothing but slope between 2 points. That is all AROC is. How do you find slope?
Rise over run.
You are all right. y2 minus y1 over x2 minus x1. I could write it the other way. y1 minus y2 over x1 minus x2. I could write it as rise over run. I could also write it as, here's the fancy way, you ready? Delta y over delta x, because delta is the Greek letter that means change. Tell me about heat, quick. No, I'm just kidding. I don't know. All right. So even though lines are the only things that have slope, every function has a rate of change, and you can find the rate of change between any 2 points whether that's a line or even if I had a parabola, this is the one that looks like one on your sheet here. I can find the average rate of change between these 2 points. This is what we call a secant line. But look, this is just fancy words for things you guys already know how to do. A secant line just passes through 2 points.
Okay, so why don't they just call it a line? Why don't they just secant?
Yep. So AROC, or average rate of change, is the slope of the secant line. That's it. If I want to know what the average rate of change between these 2 points is, I find the slope. That's it. There's nothing any more difficult to it than that. So look at number 7. That's an example there. It's a parabola. Because you have to understand what they're asking you, but at the end of the day, it's really not hard for what you're doing. All right, so it says to find the average rate of change on the interval -2, 1. Right? So to find AROC, I need 2 points. I need points because I'm plugging in slope formula, right? Well, this is saying between -2 and 1. So I need this point and this point, and all I'm going to do is find the slope between those 2 points. That's it. Because it says from -2 to 1. Here's -2. Here's 1. These are x's, not y's, yes. So, well, what is the point? So these are x, right? This is x and x. It's not a point, that's an interval.
Okay, so for the 1, you do 1 and then you go down until you hit the line.
Yes. Find the y that goes with it. And same for -2. Negative what? It doesn't matter as long as you start with that same one on the bottom. That's all AROC is. Now slope. Find the slope. So it's, all right, change in y over change in x. So y changes 8. It goes down 8, right? And x, -8 minus 0 over 1 minus -2. No, don't let it be hard. Is it? Oh, I'm sorry, y'all.
Yeah.
It's -2, 1, and then 1, -8. So it's 1, so -9.
No, I did not. Wait.
So what you got for your slope is -3.
But if you calculate, then you get a different number, y'all.
No. You don't. Your signs are just different.
Yeah, so it's not
I'm not
how'd you get 3 on the bottom?
So
It's the exact same. So this is the exact same as so why do you get -1?
it doesn't matter which point you start with, as long as whichever point you start with in the top, you start with the same point in the bottom. What? If you connect these 2 points, that has a negative slope, right?
With the 2 points that they give you, you just go up or down until they like cross an actual point, like a line.
Yes, you find the y value for that point, for that x. Sorry, y'all, I didn't anticipate y'all to have trouble with this. I'm sorry. Hold on. What? No, look at me. I'm the one that got hung up on the stupid absolute value. Oh my goodness. I got to do better. Do 8. All right, so number 8, from 0 to 4. So 0, what point is at 0? 1, 2, 3, 4, 5, 6, 7. -7. What point is at 4?
1.
So find the slope between those two.
And then, so that number is our average.
Yes. That's it, unless you have an equation. But if you have an equation, you just plug it in, right? So if I have like number 9 where f of x is...
Oh, yeah, there's not anywhere talking about our test.
Because I see this on the second page.
I don't do word problems.
No, we got -8 over...
Number 8. No, number 8. On the board. Oh, it's -7. I didn't see that. Oh, you wrote it. How did you mess with that?
I'm not arguing with anybody anymore because I'm probably the one that's wrong today.
I got -7 over 4. Yes, it's -7. It's -7 minus
Yeah,
1.
let's just not just
0
don't
minus
solve
0
it.
is 1. Or you could have done it the other way. Yeah. Yeah.
Y'all told me 4 was 1.
4 is 1. 4
What do
is
you
1.
just plug in 4D for X?
4 is 1. No, it's not. I mean, it's really close. Okay, wait, it's really close to 0 because I thought it was 0, but it is 1.
Y'all get so nasty with each other. Okay.
I thought it was 0 too. No, why is there?
This is 15. A company's total cost in dollars to manufacture X units is given by this equation. Find the average rate of change for the first 200 units. So all this is saying 0 to 200. Now remember, this is just your X, right? 15. It said the first 200 units. So from 0 to 200. So look, don't make it harder than it is though. They're giving you an equation. All you have to do is figure out this interval. In most cases, it's going to be 0 up to whatever they tell you. C of 0 is 1200. I just use that instead of F or Y. And then if I do C of 200, I don't know somebody with a calculator do that. Somebody, anybody, everybody calculate! No, where are you? Plug it into the equation. What is it? So now look, you've got your 2 points. Your points are 0, 1200, and 200, 11, 200. Find the rate of change there. A-Rock. What?
That's what I'm saying. This isn't too hard. This is foul bad. Well,
I got 50.
So for like 9 through 14, you just plug each one in.
That's just 50.
You do one of 9 through 14.
Bro, I swear to God. Oh my God, I swear to God. I'm gonna choke somebody.
Somebody, anybody, everybody run! I'm just kidding. What? Okay, yeah.
What are our homework questions? No, I don't know. No, let's see.
I think we can do. They're not. They haven't taken forever, have they?
Make this whole thing, and then
Just so the first page is easy. Go through and do that. The second page, just do odds on it, or half of them.
wait, first page.
I think you can do all the first page.
Oh, this one.
Yeah.
The graph.
Yeah.
This page.
Just all right. Listen. Just do the odds on the second page. Yeah. Yeah.
And then do the whole first page.
Yeah. I think that's. They're not hard. Those are quick. The first page. The second page is what takes longer. Yeah. Yes. You got 30 minutes. 20. All on the first page, odds on the second page. The A-Rock page. So symmetry all.
Bro, like,
A-Rock
Miss McGee, we don't have to prove
odds. No.
Oh no, I don't want to do that. I don't know.